now we can talk about number of moles in a certain volume of water. This is called molarity. The solute particles is going to be our hydrogen plus or our OH minus. But this is a very common unit in chemistry, molarities. The number of solute particles in moles, so like in dozens, mole units. When I say in mole units, per total volume. And this guy is in the metric unit of liters. Yeah. We are unfortunately the only country, I think Australia still uses it, but we're one of the few countries who uses the English system. Okay, so the reaction of an acid and a base is called neutralization. And you've done this before. You've probably eaten Tums or taken Alka-Seltzer as an anti-acid to reduce the acidity in your stomach. That was a neutralization. And it produces water when they're put together. Okay. So let's look at my two friends here. By definition, an acid produces H plus and a base produces OH minus. Together they form water. So let's write out the entire acid. It's usually written in molecular form. Hydrochloric acid. We put it down like that. And you just have to understand that when it hits the water, it does ionize to produce loose H plus. And our other friend here, sodium hydroxide. When I throw her into water, I'm going to have Na plus and OH minus. And I'll end up with, well, water again. Here are my two anion and cation, anion and cation, anion and cation. Okay, this reacts with that to make water. And then sodium and chlorine are left over, and we write them like they are a compound. They aren't really. This again is loose ions. Ion soup, if you will. We can write it as this, just to keep it clear. And that's neutralization. When we're talking about pH, we are going to measure the molarity of H plus. It's in your book under Appendix 3. The pH is a number between 1 and 14 that indicates the acidity or basicity of a solution. If you haven't done log functions before, you need to refresh your memory or learn it. But I think most people have seen it before. Okay, let's talk a little bit about it. pH stands for the power of hydrogen. And it is a mathematical function which is the negative logarithm of H plus. Notice these brackets? This means the molarity of H plus. And the molarity is equal to moles of H plus per 1 liter of solution. Okay. It's just a unit of concentration. Okay. So when we take, for example, the logarithm, let's say the concentration is, how about the concentration of H plus is equal to 1 times 10 to the minus 2. The pH is going to be equal to, the negative log of 1 times 10 to the minus 2, which equals negative 2, times the negative. So it becomes positive 2. Because it is the power of 10 that you have to raise this number to get this number, times a negative sign, negative 1 sign. So neutral is pH equal to 7. We call this neutral. And this will be equal to the negative log of 1 times 10 to the minus 7, or negative a negative 7. Right. How about another one? Well, it gets to be a little dicey up here. Well, no, but let's keep going here. For a base by definition has pH greater than 7, and an acid pH less than 7. What if we don't have a simple integer of 1 times a 10 power? Okay. So what would be, for example, the log of a log of 18? This would be equal to, you would find the log key on your calculator, and we would find it to be, wait. What if you have a concentration of H plus, equal to 18 molar? This is how we symbolize molarity. To find the pH, we would simply say we would take the negative log of 18, which happens to be negative times positive 1.2. And that would give us a negative pH. This brings up another point. pH is used for dilute solutions. Is only used for dilute solutions. That is very low concentration. We have to have it between 10 to the minus 1 to 10 to the minus 14 in order to get a pH equal to these digits, between 1 and 14. So if we had a concentration of 18 molar, it's inappropriate to use pH. Okay. What is the pH of acid rain? Well, dissolved carbon dioxide and small amounts of other natural acids combine to give normal rainwater of pH of about 3. Acid rain contains pH less than 3 by definition. Less than 5.3. That means more H plus ions in there than 5.3. Okay. Then the pH of 5.3. Water with a pH below 4 cannot sustain life.